Hello, geometry students. Mr. Zacek back and better than ever. Very short lesson here, lesson 5. We're not going to do the whole thing. We're looking at surface area and volumes of similar solids. When we think about similarity, we're thinking about proportions. Okay, and we're thinking about congruent angles that we have. So similar solids. So if we look at this first one here, similar solids, their sides are proportional. So all of the sides, when you simplify from here to here, as we simplify this, they have the same ratio. So the ratio of similarity is 1 to 2. We can also think of this as the scale factor, which we can keep in mind when we're thinking about like dilations as a transformation of similarity. All right, so non-similar solids, the sides are not proportional, okay? So when we look at the surface area of similar solids, we have the similarity ratio, which is A over B, and then the surface area is A squared over B squared. We've talked about that before. So when we look at the volumes, this is an example here. I'm not going to spend the time on the example. It's worth reading through. But if the ratio of the sides is A to B, the ratio of the areas is A squared to B squared, then the ratio of the volumes is A cubed to B cubed. Okay, so what I want to point out here is if a solid is scaled or dilated by a factor k, then the volume changes by a factor of k cubed. So when we think about these lengths, a side length is in units, surface area is in units squared, and volume is in units cubed, and that can help us keep in mind the ratios for each measurement. All right. So if two solids are similar and the ratio of similarity is A to B, then the ratio of corresponding surface areas is A squared to B squared. The ratio of corresponding volumes is A cubed to B cubed. So if a solid is dilated by a scale factor of K, then the surface area changes by a factor of K squared, and the volume changes by a factor of K cubed. All right, so if we were going to do this question, let's look at like a question like number 5. If the radius of a sphere is doubled, how does the volume change? Well, that would be 2 cubed, so it would be 8 times greater, the volume would be. If a prism is scaled or dilated by a factor of 1/3, how does the volume change? So we take 1/3 to the third, and that would be 1 to the third over 3 to the third, so that would be 1/27th. All right. There is one thing I want to show you on the calculator that is a little bit different, and it's probably not going to show up in this case, but how do we, let's say we have A cubed, how do we go from A cubed to A? Well, the way that we do that is we take the cube root. So how would we find, for example, the cube root of 27 on our graphing calculator? And so it's going to be this button here. We're going to hit Control and then above the exponent. And then in this spot here, you have to put in which root you want. So the cube root of 27, okay, would be 3. So that might show up, for example, in a question where if you know the volume of the sphere is 4/3 pi r cubed, and let's say, I'm just making up some number, let's say the volume is 50 and you needed to find r cubed. Well, you could multiply by 3 first to get rid of the fraction. So 150 would equal 4 pi r cubed. Then we would divide by 4 pi. Okay, so divide by 4 pi. Now when you do that division by 4 pi, create the fraction first. So 150 divided by 4 pi. If you don't do it that way, you'll get the wrong answer. Now we want to take the cube root of that, so control and this little thing here, the cube root, and then I'm going to hit control and the negative sign. That puts my previous answer in, and you see it put that 11.93 in, and so it would be 2.28 would be your volume. So I just wanted to show you that little calculator thing, because that is something that you might need. Okay, so this is not a major topic, but and you know, we haven't ever seen the volume asked. We have seen the area ones asked before, but I just wanted to introduce it to you. It is in line with it there, and so we'll see you back here for the last lesson of the year, which is on density next time, and that is a very important topic. All right, see you soon.